Alright, in this video I'm going to do a review of projectile motion. So I've already set up a problem. We're going to start with the simplest example where we just have some object that's going to be fired off a cliff horizontally at some velocity v. So the displacement in the y direction is going to be s sub y, and the range of the projectile is going to be s sub x. So the first step in doing these problems is to figure out how long is it going to take for the object to reach the ground. So in this problem it's easy to solve because this equation we're going to use right here simplifies. The equation, the displacement in y is equal to the initial velocity in y times time plus 1/2 gravity times time squared is the equation we're always going to use to find the time in the vertical direction. So if we have a projectile that's dropped, I guess that wouldn't necessarily be a projectile, but if you just drop an object, you would use that equation. But if it's a projectile, you use that equation as well, no matter what the situation is. It's just important that you're going to use the velocity in the y direction, since we're dealing with gravity in the y direction. Okay, so in this example then, that equation is going to become s sub y is equal to 1/2 gt squared. So that's nice that we have no vertical velocity in this problem. Therefore, that piece drops out. This equation then we can easily solve for time, and this equation should just be ingrained in your brain if you work with projectiles a lot, and you get the square root of 2 times the displacement in y divided by gravity. So let's go ahead and plug in some numbers and figure out what that's going to be. Alright, so we have the square root of 2 times negative 30 meters. So I've already chosen the numbers for this problem up here. And then you can't forget that you have to make gravity negative as well, because it's pointing down. And if you forgot the negative, you're going to get the square root of a negative number because of the negative 30 up here, which would give us an imaginary time, and we can't have that. So let's go ahead and calculate that. So we have 2 times negative 30 divided by 9.8. Well, a negative divided by a negative is a positive. So we have 2 times 30. So there we go, 2 times 30, which is 60, divided by 9.8. And then I want to take the square root of that number. Okay, so square root of that, and we get about 2.5 seconds. So let's just go with 2.5 seconds. Alright, here we go, 2.5. Alright, so what's the next step? Now we know how long it's going to take for the projectile to reach the ground. So you have to remember now, well, how is it moving in the horizontal direction? It's easy. It's a constant horizontal velocity, so we just use this equation. We don't have to worry about any acceleration. That's just a property of projectiles that you have to remember. The acceleration is only in the y direction because of gravity. Objects don't just start accelerating in the x direction unless there's some other force acting on them. So the last step then is going to be, let's find the displacement in x. It's going to be the horizontal velocity. And the horizontal velocity is simply the velocity the object was fired off in the first place. Because if it's fired off only across this direction, right off the cliff horizontally, in the x direction, it has no y direction, and all the velocity is in x. So Vx is 10 meters per second. And we just found how long it's going to be traveling in the x direction. That's 2.5 seconds. We don't need a calculator to do this one. 10 times 2.5 is just 25 meters. And so the range of this projectile is going to be 25 meters. And that's usually where these problems would end. Sometimes they may ask you to find the velocity here. And you have to remember that the object is not only moving in the y direction, but it still has its x component of velocity as well. And so if we add those vectors up, as in the parallelogram method, which I didn't draw very well. This right there is the actual velocity. That's going to be the x velocity. That would be the y velocity. And you can figure that out by just taking the initial y velocity, which in this case is 0, and then plus gravity times time. And then you would just add those vectors up using the Pythagorean theorem. Vx squared plus Vy squared is equal to the final velocity squared. And then, of course, because it's a vector, you must also use the tangent to find that angle right there. So hopefully this was helpful, and I'll do another video. Excuse me. I'll do another video on some more complicated projectile problems next time.